Let's talk about the properties of multiplication. And I apologize that this is crooked here, but these properties should look pretty familiar to you. Our first property here, our commutative property, is the same commutative property that you've always dealt with. The order in which two numbers are multiplied does not change a product. Basically, just like adding, you can change the ordering of multiplication. 3 times a negative 2 is going to be a negative 6, just like negative 2 times 3 is going to be a negative 6. And feel free to pause the video if you want to write any of these down, because I'm going to move through them pretty quickly, considering hopefully they're review for you. The associative property, that changes the groupings of numbers. Okay, so for example, you can see it in algebra here. This means it works for any A, any B, and any C. But if we look at this example, notice the order of our numbers doesn't change. What changes is where the groupings are, where the parentheses are. So in this case, we have the quantity negative 6 times 2, then times 3. And over here, we have negative 6 times the quantity 2 times 3. It's still negative 6 times 2 times 3, but where the parentheses are moved. Negative 6 times 2 is negative 12. We have a negative 12 times 3. And over here we have negative 6 times 6. You should see that negative 12 times 3 equals a negative 36, and a negative 6 times 6 equals 36. So again, basically if you follow order of operations, here we multiply with the negative 6 times 2 first, because it's in parentheses. Here we'd have to multiply the 2 times 3 first. So the way we group our numbers doesn't matter when we multiply. Our identity property, that just states that if you multiply a number by 1, the number keeps its identity. 1 times any number is going to equal that number. Negative 4 times 1 is going to equal negative 4. Okay, it keeps its identity. It's the identity property. The property of 0, this is something you already know. We just have a property to say that it's always true. If you multiply 0 by any number, you get 0. Negative 2 times 0 is 0. 1,032,000 times 0 is going to be 0. And then our property of opposites. This one might be new to you. It says the product of a number and negative 1 is the opposite of the number. So if you take negative 1 and multiply it by any number, you get the opposite of that number. For example, negative 1 times a negative 3 equals 3. The opposite of negative 3 is 3. If you take a negative 1 and you multiply it by 8, you get the opposite of 8, negative 8. Kind of common sense, but there is a property that we can always get the opposite just by multiplying it by a negative 1. Now really, these properties are to help us use mental math to solve problems. That's what I mean. This is what I mean. Evaluate the expression when x equals negative 7. So we see here, we're going to input a negative 7 in for each of these x's. Be careful. This is 2 times a negative. What is x? Not there's already a negative sign, I'll make this a negative 7. This is negative 7. Okay, again, we're going to be dealing a lot more with negatives than with variables, so we have to be careful. Same thing here. That's why a lot of times you hear me refer to this as the opposite of. This is like saying times the opposite of x. Well, what's x? X is a negative 7. Okay, really kind of crazy and confusing here, but if we do this problem, this ends up being 2. Well, what's the opposite of negative 7? Again, if you think of it as negative 1 and we multiply negative 1 by anything, we get its opposite. So the opposite of a negative 7, 2 negatives, it's a positive 7. Same thing here. The opposite of negative 7 is a positive 7. Okay, so that's just kind of using that property of opposites. If you look at this here, what order of operations tell us to do is go 2 times 7, which is 14, and then go 14 times 7. Not that that's a problem, not that we can't do that, but we could use our associative property and change the grouping. Here's what I mean. If I multiply 7 times 7 first, we get 49. 2 times 49 is probably a little easier to do in your head, because 2 times 49, we can think of it maybe as 2 times 50, which is 100, and then 2 less, is going to be 98. Okay, so if you put in some grouping symbols, like I put in the brackets here, that's the associative property. Just be aware that we might do these things anyway, but there's a property that says it's okay to do them. And that's what these properties do. They allow us to manipulate numbers to make it easier for us to evaluate them. Looking at this next example here, it says the quantity negative 5 times x times negative 2/7. Okay, again, we're going to substitute negative 7 in for wherever we see an x. So this is negative 5 times, instead of x, I'm going to say negative 7, and then times a negative 2/7. Well, you could definitely do this problem and go negative 5 times negative 7, get 35, and then times it by this. But if we change our parentheses from around these two to around these two, meaning if I go negative 5 times negative 7 times negative 2/7, notice the cool thing here. These 7s are going to cancel out. Cross products, or I'm sorry, not cross products, cross reducing. What do 1 and negative 2 have in common? Nothing. What do negative 7 and 7 have in common? Well, they have a 1 in common. So we can go 7 goes into a negative 7 a negative 1 times. 7 goes into 7 1 time. What that becomes is a negative 5, just 1's in the bottom, so negative 1 times negative 2 is a positive 2, and that equals negative 10. Okay, again, if you would have done negative 5 times negative 7 and gotten 35, 35 times 2 divided by 7, making it negative there, you would have got the same answer. But just by using our associative property, again, moving our grouping symbols, we can maybe solve this a little bit easier in our head.